Hi guys, this is the video tutorial for the quiz review worksheet. This is really important. If you're tuning in, I'm actually going to go through the answers with you because tomorrow's the quiz. Hopefully tomorrow's the quiz. And you're studying the night before. Hey, you could have actually studied this on Monday, I suppose. But anyway, let's go ahead and get started here. I am going to go ahead and assume that you have read the setup for at least problem number 1. And we'll come down to problem number 2. I really like this problem, but let's start with problem number 1. Now, you're going to have to forgive me. My drawing isn't very good, but of course, you recall the problem is about Cody here, and he runs his entire workout, or doesn't run his entire workout, but Cody runs. Of course, we know Cody, and he is out for cross country. So I figured I'd make some problems about you guys every once in a while. He's running. So anyway, here's kind of the setup for the problem. Cody is running his workout now. I say, here's the start, here's the finish, there's Cody, he's kind of tired, and I say, hey, from here to here, we consider this one entire workout from start to finish. However, he's not doing the same thing the entire workout, so here's what I did. Now, this isn't necessarily accurate distances, but what I've done is I've drawn myself a diagram so that I can actually see what's going on here. And here's what I know. Already from the information given, Cody ran 3/5 of his workout to begin with. Hey, if we want to convert this to a decimal, that's 0.60. He's run 60% of his workout. Hey, there's nothing wrong with converting to decimals to help us out. It's easy to think about money sometimes. Then we notice he walks 1/6 of the workout as soon as he's done running the 3/5. You know, he needed a little breather. Okay, forgive the kid. He works hard. But 1/6 as a decimal will be 0.166666666, and we'll cap it off with the 7 around it. That's about 16% of the workout he walked. And then we say he runs the remainder. Now, here's what I don't tell you. I don't tell you how much he ran at the end of his workout. So the first problem says, okay, well, you know he ran 3/5, and then he walked 1/6. How much did he run? Here's what I know. If I were to add all three of these things together, that would be one entire workout. That'd be one whole. That's the same as like 1 over 1, 2 over 2, 9 over 9, pi over pi, Cody over Cody even. Try me, okay? It's a whole fraction. So here's what we need to do. We need to determine what this leftover was. We could settle this actually by taking care of finding out how much did he actually do so far up into this point, and then subtracting that off of the entire workout. Because in terms of geometrically, a difference or subtraction problem, if we were to take this from here to here, which is what we actually know what he was doing, you know, we know that part, and subtract it off of this, okay, what that does is geometrically leave this little sliver over here that we're trying to determine. So our first task would logically be to do this. Let's find out what 3/5 plus 1/6 is. Now, of course, hey, if you're not sick of hearing me say it yet, we can't add these things together yet. And the reason why is because, well, they're not the same type of thing. They're not the same size pieces, okay? Not the same denominator. So we need to find a common denominator. So here's what we'll do. The least common multiple between 5 and 6. Let's start peeling through them in our head. Of course, 5 is 5, 10, 15, 20, 25, 30. You know, I stop at 30 without even going through my 6's. I say 30, 6 and 5, they both multiply out to be 30. And as a matter of fact, that is their least common multiple. Now, before I proceed with that, I do want to mention this. Look, you could use a common denominator of 60, 90, 120. Hey, go after 300. 3,000, 3 million, see what I care. But you know what, if you're like me, you're lazy. Well, not lazy, you value your time. So let's just go with the least common multiple. And you're going to notice that pattern that keeps popping up with fractional sums and differences all the time, which is, hey, in order to turn this into 30, I'm going to be taking it times 6 on top and bottom. The scale factor must be consistent. Otherwise, it won't maintain equivalence on the new fraction. But here's the deal. Where did I get 6? Right there. Hey, what am I going to take times 6? 5. Where did I get the 5? Right there. So we're alternating this multiplying. And you know what? It's not a shocker here that now we're going to have 30ths plus more 30ths. And you know what? I'm going to end up with a sum that is 30ths. You know why? Because I made that happen. I wanted that to happen. What I really care about is this. What is 3 times 6? 18. 1 times 5. Oh, you better get this one before I say it. It's 5. Okay, and then 18 plus 5, not a shocker here. 23/30ths. Now here's what I would challenge you to think. What does this 23/30ths represent? Okay, well this 23/30ths isn't necessarily all running. He ran and walked. But here's the deal. This represents the portion of his workout that we actually know what occurred. This 23/30ths is what occurred between here all the way up to the point where we don't know actually what happened. And I would say, hey, if I know from here to here is 23/30, what's the leftover? We said, well, the whole workout is one whole workout. One. Well, what can I add on to 23/30 to bring us up to 30/30? Okay, I think that logically we might say that it was 7/30. I can prove it. 23/30 plus 7/30, boom. 30/30. Booyah, Grandma. Okay, so here's the deal. Answer part A, we would say, okay, well, Cody ran 7/30 at the end of his workout. Okay, hey, now that I know this is great because part B here, part B said, well, he wants to know how much total he ran for. Well, hold on. Now what do we know? Well, we know he ran for 3/5 at the beginning, and we also know now that he ran for 7/30. Hey, how can I find that total amount of running? I can put these two pieces together, and putting things together, of course, we know means addition. Okay, so hey, 3/5 plus 7/30, let's just go ahead and do it, right? No, I don't think so, because, well, we have to have a common denominator. Okay, so start thinking, what's the common denominator between 5 and 30? Oh yeah, 30, because we kind of already talked about that. Well, anyway, hey, sorry, I'm kind of going into part B here where I set aside some room. Here's the deal. If I wanted to add 3/5 to 7/30, hey, cool story. We don't have to mess with the 30. Let's transform this or scale it up by a factor of 6, okay? But if you do it to the bottom, remember you got to do it to the top. And we've done this once already. I don't know if you recall, but we got 18/30. We're going to get that again. Check this out. 18/30 plus another 7/30 would be a total of 25/30. Right? 1, 2, yeah, okay. 25/30 ran, okay? And this is not a shocker to me because here's the deal. If he ran for 25/30, that makes sense because he walked for 5/30. As a matter of fact, to be really honest with you, you're going to hate me for this. We didn't necessarily have to go through that process to find that out because I know that if you walked for 5/30 of it, the rest of it was running. So, hey, what can I add to 5/30 to bring me up to 30/30? 25/30. Anyway, here's the deal. We figured it out. We did it the cool way. We're math geeks, and that's great. Okay, now moving on. Number 2, here's the deal. We're talking about Vance. If you know Vance, Vance likes to sleep. So I kind of created this problem for Vance here, and I said, well, hey, last summer, here's Vance's sleeping schedule for an entire week. That's 7 days. Here's all I wanted to say to you before you do this on your own. Actually, you're going to do it. Is this. These are all mixed numbers, with the exception of this one. You might say, well, it's not a mixed number. Well, I'll tell you what. We can make it 14 and 0, whatever else. I don't care. We could put n down here to represent a number. But here's the deal. You can kind of interpret that as a mixed number. But, hey, not necessarily. Not necessary. If we were adding up money, okay, and we said, hey, $12 and some change, $11 and some change, $9 and some change, look, you'd add your dollar bills first. So here's what I'm kind of trying to push you towards. I would take care of adding together all of these whole numbers first, and then adding the fractional parts. Now, I was nice to you on this. I'm not as nice to you on the quiz tomorrow, or whenever you're doing this. Whenever we take the quiz, I'm not as nice because here's the deal. I give you fourths, and fourths, and fourths, and fourths, and fourths. Whew. Okay, so I gave you 1/2. Big deal. Change it into fourths. It's not going to make you cry, promise. And if it does, just don't call me any names to my face, please. Hope this helps you with your homework.